On the other end of the cylinder block is this piece. What it does is it just provides a mechanism for this rod to go back and forth and move the displacement piston. There's nothing overly complicated about this. It's just some turning in brass. This darker gray area is a piece of graphite that I'm going to have to machine, I will just Loctite it into this larger cylinder, larger adapter, and then we'll drill it to let this this rod pass through. So let's go make that part. I'm about to do some drilling, which is almost always done with the tailstock. I've probably mentioned it before. I just don't like the lack of rigidity in the Shoreline tailstock. As you extend the ram, which of course you have to do when you're drilling, there is play, and there's just no two ways around it. It's just the way the mechanism is built, and I'm just I don't know, I'm just not comfortable with that, especially when you get to reaming, which we're going to have to do on this part. So what I'm trying instead, and this is the first time I've done this, is I've set up a drill chuck on the cross slide. This, to me, has a lot of advantages. One, it's very rigid, and secondly, I can use CNC now to do peck drilling, for example. Which obviously you can do that manually, but it's a lot of work. Here I can just sit back, let the machine do it, and all I have to worry about is keeping the chips clear. So the way I've set this up is, before I put this here, I used the existing tailstock. I put the a center drill in it, and I center drilled my part. Then I moved. Then I set this up, and I made sure that it was, it's certainly, square to the cross slide. I know that this tool post is dead on its center height. It was built that way, and the only thing you have to do is, find that point, in the X direction where the drill is lined up, and that's just a matter of, the way I do it is I put the same center drill in here, and I come forward, and then, under magnification, I look, at where it is, and I make small increments back and forth in X until I'm, dead center. And once that's set up, I just set my DRO that is X0, and I leave it alone. I'm not going to move the cross slide anymore now. So let me reposition the camera and I'll show you what I do from here. Alright, so now I'm just going to advance the drill bit until the tip is right at the part. That's just done visually. Now I set my DRO in Z to be 0. Back it out. I've written a little G-code program to peck drill, through the full depth of this part. So now it's just a matter of lubricating the bit and running the G-code. And that's all there is to it. I made a couple of sample parts before, and I measured, and then I flipped the part around to make sure that I was getting an exactly straight hole, and I am. And that's something that, like I said, I've just never been comfortable with doing it the old-fashioned way. So this is the way you'll see me drilling from now on. What I'm going to do now is just switch over to a reamer and take care of that. When I ream, I go at a much slower speed, somewhere around 700 RPM. Lots of cutting fluid in your reaming. Now the way I do reaming is, again, low RPM, around 700, and then I'm just advancing the tool in at a feed rate of 0.75 inches per minute, which obviously is very slow. And when I reach full depth, I back it back out at a feed rate of 2 inches a minute. And I find that gives me a really nice finish. It's coming back out now. This part's almost finished now. I did the turning off camera. I mean, there was nothing special about that, but this is, the part we looked at that's going to, next I'm going to machine a graphite cylinder, which is going to end up being a bushing. It's going to be, glued in here the full length. Then we'll mount this part up again and drill a smaller hole through the graphite so that the main drive rod can go back and forth through it. So that's where we are. Thought I'd let you take a look at the finished adapter here with the two O-rings. So now, when I press this in, it is a very, very snug fit. Now, again, the tube will obviously be cut a lot shorter. It's only about, that long when it's done. But, that will go on this end of the cylinder block, and the other part on this end. They'll both be Loctited into position. So we're making some nice progress here. Well, it's time to do something crazy, I guess, but we're going to cut Pyrex glass using the lathe and a Dremel tool. This is a very tricky operation. What I'm trying to do is just cut off this, this small segment here, which ends up being the displacement cylinder. There are many problems involved in doing this. One is glass, and it's very, very fragile. Grabbing it in the chuck is problematic. So what I've done, I doubt you can see it, but I've taken a rubber cork and stuck it inside the test tube. Test tubes typically come with these, and then blue tape around the outside just to get a grip on here, and then tweaking this down. I've already broken 2 test tubes just getting it set up. So when you buy your test tubes, if you're going to make one of these, buy more than one. Now with the Dremel tool, I've got a diamond cutting wheel in here, and I'm going to put the Dremel on a relatively low speed, and I'm also going to put the lathe on a relatively low speed, and then using the hand wheel on the cross slide, I'm going to advance the Dremel tool into the part, and I'm going to keep it soaked in water because it's going to get hot. Very, very slow feed. I'm hoping when I do finally cut through, that when the good end falls off, it won't break. I just don't have enough hands hatchet. Must be the quick coil. All right. Well, that's not bad. What I'd love to be able to do now is mount this in the chuck and sand this edge, because I should be able to get a really nice finish on that. The problem I may run into is it's going to be very difficult to hold this end of the chuck because the end here is larger than the hole, but I'll try to set up and do that. All right, I've flipped the cylinder around, and the rounded part is sitting in the chuck, and the holding power is, well, let's just call it precarious. But I'm going to what I'm going to try to do. See, when the wheel did its cut, it wasn't a perfectly clean cut. So what I'd like to do now is turn the Dremel tool on and then just jog it very, very slowly, thousandths at a time, just to get a square edge on here. Alright, that actually did a nice job. So now I'll just get the Dremel tool out of the way. And now all I'm going to do is use some wet sandpaper. Just put a little bit of a bevel on here so that will make sure the inside is free of any chips. I'm applying very light pressure, and I've got the sandpaper nice and wet with water. This This piece of sandpaper I'm using right here is emery paper, and that's just to get everything nice and flat and smooth. And now I can switch to my regular micro mesh papers that I use for everything else. And, you know, we don't have to get crazy. You're never going to see this part. It's, you know, well inside the cylinder block, and it's, you know, flush to one of the brass borings that we did. I just don't want any, you know, I want it as clean as possible, but this is just me being obsessive at this point. I started with 1500 grit, went to 1800, this is 2400, and this is probably as far as I have to go. You know, the glass at this point should have, well, it should be back to being clear again. You know, because it frosts when you cut it out of this thing. That's nice. So we've got a nice clean edge here. I'll go clean these things up, and once again we can move on. I thought I'd just give you a quick look at the setup I've got here on my Dremel tool. It's nothing complicated. I've just created a, you know, an L shape with two pieces of 3/8 inch aluminum. This one has holes drilled to connect to the T-slots and the cross slide. And then I just have a piece here. There's a hole drilled through it, which it's not drilled, it's actually bored through here on the mill, but you know, you'll have to figure that out to match whatever size Dremel or equivalent tool that you have. And then it's slit with a set screw here that, you know, allows me to clamp it down. And like I said, the only trick is making sure that your center line here lines up with the center line on the headstock. And that's no big deal because, you know, once you got to this point, if you wanted to, you could just mount this on the cross slide, put a center drill in the chuck here and advance it in, and that would, you know, mark where the center line is, and then you could just mill from there. I didn't make all this just to cut test tubes. What I actually originally made it for is cutting axles. For, you know, this project is going to have a lot of axles for, you know, holding the gears and the pulleys and the flywheel and all that other kind of stuff. So, you know, I put steel rod in here. I put in a, you know, a metal cutting wheel. And this lets me cut very precise lengths, you know, whatever length I need. And I'll be doing a lot of that later. This adapter in here that actually supports the displacement piston. And although I haven't drawn it in yet, these two grooves here are for O-rings. And again, this is a nice, you know, tight press fit into the glass tube, you know, which will allow this, you know, to reciprocate. You know, it's got a boring in here that fits over this, you know, to get a nice, you know, to press all the air out. So let's go make this. I've begun working on the adapter that will hold the displacer piston inside the displacer cylinder. It's a small aluminum piece that I've machined down, so it's just a hair smaller than the glass cylinder or piston. And what I'm about to do now is make some grooves for O-rings. These O-rings will, there'll be 2 of them on here. They'll cause a nice press fit the piston onto this part. I'm using the standard cutoff blade. The tool we used before to cut the O-ring grooves was designed to cut inner O-rings. So that tool won't work in this configuration on the outside. So I'm using the standard cutoff blade, which is, first of all, it has a flat edge to it, so it'll give me a flat bottom in here. It's 40 thousandths wide, and we need an 80 thousandths wide groove, so I'm going to have to, cut in and then move over 40 thousandths and cut again. This will be done just by turning the hand wheel. We'll do some some trowel cuts, we'll do some fitting, and nice slow spindle speed, plenty of cutting fluid. Gonna come in until I just touch. There. Now I'm going to zero the hand wheel. Okay. And then I'm going to come in 70 thousandths. Okay. Now I'm going to move over 40 thousandths. O-ring on there. Let's see where we are. Actually, where did that go? I'm going to use one of the cut-off pieces from that same test tube to test with, just in case I press too hard and break it before I'm sure what's going on here. No, that's perfect. It's not, you can tell that that's the kind of grip that we want. That's not going anywhere. All right. So that's the idea. I'm going to move over a bit and cut another one identical to this, and then I'll part this off, and this piece will be done.